Signals and systems. First question. Important questions for external examination. Explain about unit impulse function and state and prove any three properties of unit impulse function. Okay, first unit impulse function అంటే మనం x యాక్సిస్ మీద టైం పీరియడ్ అండ్ y యాక్సిస్ మీద ఫంక్షన్ రిప్రజెంట్ చేస్తాం. జనరల్గా ఇక్కడ యూనిట్ ఇంపల్స్ ఫంక్షన్ని డెల్ ఆఫ్ టీతో రిప్రజెంట్ చేస్తారు. యూనిట్ ఇంపల్స్ ఫంక్షన్ అంటే ఓన్లీ జీరో టైం పీరియడ్ వద్ద ఫంక్షన్ వాల్యూ 1 ఉంటుంది, రిమైనింగ్ జీరో అనమాట. రిమైనింగ్ టైం పీరియడ్లో నెగిటివ్ టైం యాక్సిస్ అండ్ పాజిటివ్ టైం యాక్సిస్లో కూడా జీరోనే ఉంటుంది. సో డెల్ ఆఫ్ టీ ఈజ్ ఈక్వల్ టు 1 ఫర్ t ఈజ్ ఈక్వల్ టు 0, 0 వద్ద 1 ఉంటుంది, అండ్ 0 ఫర్ t నాట్ ఈక్వల్ టు 0. t 0 కానప్పుడు ఫంక్షన్ అనేది ఏముండదు, 0 ఉంటుంది. ఇది యూనిట్ ఇంపల్స్ ఫంక్షన్ అంటే. యూనిట్ ఇంపల్స్ ఫంక్షన్ అంటే ఇట్ ఈజ్ 1 హ్యావింగ్ మ్యాగ్నిట్యూడ్ 1 at time t is equal to 0 and having magnitude 0 at time t not equal to 0. This is the definition of unit impulse function. It is for continuous time signal. Why? Because we are taking del of t. For discrete time signal we are taking like this, del of n, that is equal to same 1 for n is equal to 0, 0 for n not equal to 0. For this also graph will be same. How the graph will be same? Similarly we are taking x-axis and y-axis. X-axis we are representing discrete time. Here del of n is only 1 for n is equal to 0, remaining 0. This is about unit impulse function. Now coming to the properties. First property, integration of minus infinite to infinite del of t dt is equal to 1. To prove this property we have to use graph. Same, we have to draw the impulse signal, that is t and del of t. It is 1 at 0, remaining zeros. If we apply integration on this graph, we have to summation of both negative and positive up to infinite. But if you identify here only 1 at 0, so we have to write integration like this, del of t dt is equal to del of t at time t is equal to 0. Only here only signal represents, remaining signal is not there, so remaining all are zeros. Only t at the place of t we are getting signal. So del of t at 0, del of 0, that is equal to del of 0 how much? 1. So hence it is proved. Okay, next property, second property, I'll write here second property. Del of n is equal to u of n minus u of n minus 1. Okay, for this I'll consider this as LHS, this as RHS. First of all, considering RHS, I draw first u of n, unit step signal. That means the signal is presenting at positive sides. Here 1 and at 0 1, at 1 1, like this, 1 3 1, like this. This is the unit step signal. Now for finding u of n minus 1, right shift here 0, there is no signal. Here 1, there is a signal. 2, there is a signal. Here magnitude is 1, magnitude is 1. Okay, 1. Here 1, like this. This is u of n minus 1. Now subtract this u of n from u of n to u of n minus 1. Now these are cancelled. Remaining is here. Now I'll got like this. If I try to draw the graph of u of n minus u of n minus 1, these both things are cancelled here 1 at 0. So if you observe here at 0 the signal is presenting 1, so it is equal to del of n. Why? Because you know definition of del of n, that is equal to 1 at n is equal to 0, 0 at n not equal to 0. This is the impulse function. This is about second property. Coming to third property. Now del of t into f of t is equal to f of 0. You consider f of t is some function. Okay, now I am taking this f of t is, I'll draw graph f of t like this. Now I am taking f of t as a my function. Here I am considering this signal. Okay, now I know del of t is only 1 at 0, remaining all are 0. Now multiply. Here it is f of 0, here it is f of 1, here it is f of 2. But if you observe one thing, f of 0 into del of 0, f of 0 into del of 0, that is equal to f of 0 into del of 0 at del of 0 is equal to 1, that is f of 0. At remaining places, f of 0 into del of 1, 0. Why? Because del of 1 is equal to 0, del of 2 is equal to 0. Only at 0 we have a signal. That's why we are getting graph will be like this. At whatever the signal presented del of 0, f of 0, that only here comes. This is equal to f of 0. At all remaining places it becomes 0. It becomes 0. Only f of 0 is presenting. So del of t into f of t is equal to f of 0. Hence third property also proved. Third property proved. This is about first question.